Welcome to the video demonstration of dCenter. In this video, we will present what are the issues on deploying AI service on federated resources, and what are the dCenter benefits for them and to stakeholders. Recent survey from dCenter shows that many stakeholders showed their interest on dCenter platform. Around 90% of respondents told that they will adapt dCenter in their business, and dCenter will be useful on their needs. However, they also told that adopting dCenter platform will have kind of learning curve, and will take long. Regarding this concern, this video will present each stakeholder the benefit of dCenter with identification of key components and short demos. Before we continue, we'd like to give a brief recap on what is the purpose of dCenter platform. More details on dCenter concepts can be found on our website, also on other video files on this YouTube channel. This figure depicts dCenter architecture. It consists of platforms and tools to create AI-based cloud-native applications and operate them over independent or federated, heterogeneous cloud-to-edge infrastructure. The blue boxes on the figure are platform modules while the red ones are tools. dCenter can be defined as a set of software modules that provide independent functionalities. Rather than a platform with a monolithic architecture, this architecture provides more flexibility on composing and maintaining a service. Each module has its own benefits and related stakeholders, and in this video we will focus on practical benefits of them on use case for implementation. In this video you can see how dCenter provides benefits on intuitive configuration of an AI service with AppComposer, monitoring of deployed services for application-specific metric, and management of a trained model for a running container. The motivation of use case 4 is to implement an ambient intelligence service in smart offices. This AI-supported smart signage service provides interactive signage service according to a person's membership status. When a person comes in front of the camera of a signage device, the AI will determine the affiliation of a person, and then display corresponding information on the display. The service is composed with a microservice architecture. It consists of 4 kinds of microservices that are connected to each other. This enables flexible placement of resources using dCenter platform. Now let's see what are the dCenter benefits on realizing this use case. The first one is service configuration with AppComposer. For the configuration of deployment and related resources, it is usual to describe them in YAML files and use command line interfaces. However, when it comes to the AI, it becomes complex since additional care needs to be taken on selection of AI-capable resources. The AppComposer of dCenter provides very intuitive methods to this configuration, with the help of CRDs for managing heterogeneous resources. Using the AppComposer GUI for service composition is very straightforward. You can drag the components you want to use from the left sidebar to the canvas, and connect them by a line. You can configure the microservices by double-clicking it. Here you can define attributes of a microservice, including the specific AI-capable resources and region. Specific configuration on AI microservice can be also configured with this GUI. For example, the input and output parameters of the AI microservices can be configured. When the service composition is completed, you can ask deployment of them using this GUI. Also it can be saved and reloaded at any time. Let's move on to the monitoring of AI service. dCenter can be used to provide insights of AI service running with the platform. Usually it needs a few tools for resource monitoring of a service on a cloud such as Prometheus, and the resources are generic ones such as CPU, memory. However, in AI service it needs to be able to see the application-specific metric with resource usage metric. In UC4, we collect delay of AI processing, and end-to-end delay for the service. Those metrics can be found on left and right bottom of the GUI, respectively. The GUI can collect metrics on different configurations. Here the comparison of processing delay between embedded GPU and PC GPU is depicted in the left bottom, and the comparison of end-to-end delay between all edge deployment and edge cloud deployment in the right bottom. Last but not least, the benefit of using AI model repository will be presented. The main purpose of AI Model Repository is to manage data for cross-border application deployment, and it can provide additional benefit on model substitution. When model is updated, it needs to rebuild the container to include new model, and redeploy of the container. This will increase downtime of a service. The AI Model Repository enables substitution of a model on a running container without restarting or redeployment. The dcenter AI package provides RESTful interface to request update of an AI model from dcenter AI package. UC4 GUI has an interface for that. By writing down the model information and clicking the button, the model will be updated on a running container. The test shows that about 30% of delay can be reduced with dcenter tools. This video presented benefits of using dcenter on implementation of AI service. The stakeholders such as AI application developer, resource manager or infrastructure manager can take those benefits. More benefits of dcenter platform can be found on other UC videos in this channel. Thank you for watching. Hope this helps you to implement various AI services with dcenter. More resources can be found on our website, http://dcenterproject.eu.